Would you dare kneel beside a muddy watering hole, scoop up a handful of cloudy water that wild animals had just been bathing in, and drink it? Picture an ancient human doing exactly that, crouched at the water's edge and drinking straight from nature. For us today, a contaminated source like that could cause severe stomach illness and, in serious cases, even lead to hospitalization. Yet our ancient ancestors depended on wild water sources for millions of years and still managed to survive. So what was protecting them? Drinking water from the wild. Many people imagine that water in the ancient world must have been pure and crystal clear. But natural water has always contained mud, animal waste, microorganisms, and potentially dangerous pathogens. The absence of factories did not mean every stream was sterile. Ancient humans had no modern filtration systems, chlorine treatment, or purification tablets either. They still had to drink from rivers, springs, ponds, and other natural sources every day. And that makes the original question even more puzzling. Was the secret some kind of naturally superhuman immune system? Not exactly. The immune system is only one part of the body's defense, especially once harmful microbes have already entered. The deeper explanation lies in several layers of protection created by both human biology and a mobile hunter-gatherer lifestyle. To understand how those defenses worked, follow the journey of that dirty mouthful of water after it was swallowed. The first major barrier was already waiting below. Its first destination was the stomach, an intensely acidic chamber hostile to many microorganisms. The stomach does far more than store food and break it down for digestion. Its acidic environment also acts as a powerful biological barrier against microbes entering through food and water. Pathogens arriving with a contaminated drink are immediately exposed to harsh chemical conditions. Many never survive long enough to travel deeper into the digestive tract. The body's first major line of defense, in other words, is acid. And that acid is remarkably strong. A typical human stomach can reach a pH of roughly 1.5 to 2.0, an extremely acidic environment sometimes compared, in broad terms, with the acidity found in battery acid. Gastric fluid can damage or kill many harmful microorganisms relatively quickly. So even when a mouthful of natural water carries dangerous microbes, those organisms still have to survive an acidic chemical barrier before they can move farther into the body. The stomach's hidden power. What makes this even more interesting is that the human stomach is highly acidic compared with many other primates, particularly species with heavily plant-based diets. Humans fall toward the more acidic end of the spectrum, closer to animals that regularly encounter food carrying heavy microbial loads, including scavengers. It is a strange thought. A modern person eating in a clean kitchen still carries an unusually powerful chemical defense inside the stomach. The obvious question is why? One possible explanation reaches far back into human evolutionary history, when our ancestors sometimes scavenged meat from animals that had already died. Such meat could carry dangerous microbial contamination. Strong stomach acidity would have provided an advantage by destroying many pathogens before they reached the intestines. Over time, this highly acidic digestive environment may have become an important evolutionary defense, and a system that helped protect our ancestors from contaminated meat could also have helped when they drank from less than clean natural water sources. But even this acidic filter has limits. Drinking a large volume of contaminated water can temporarily reduce stomach acidity while also delivering a much larger dose of microorganisms. Some especially resistant pathogens may survive and continue into the intestines. But getting past the stomach does not mean they have escaped the body's defenses. Below them is not an empty landscape. They are entering an ecosystem already crowded with resident microbes where another layer of protection is waiting. That second layer is the enormous microbial community living throughout the gut. Trillions of microorganisms inhabit the digestive system, forming an ecosystem that can weigh well over a kilogram and function almost like a densely populated biological territory. These organisms feed, compete, interact, and occupy available space. Human beings and their gut microbes have evolved alongside one another for an immense span of time. So when harmful bacteria arrive from contaminated water, they are not entering an empty room. They are entering territory that is already occupied. A stronger gut than ours. And this is where the story becomes even more fascinating. Evidence from ancient remains suggests that past human populations often carried gut microbiomes that were more diverse than those commonly found in modern urban populations. Researchers studying ancient fecal material have identified microbial lineages that are now rare or missing in many industrialized societies. Their intestinal ecosystem may have looked more like a dense, complex forest, while ours can sometimes resemble a more simplified landscape. But why would greater microbial diversity matter when contaminated water entered the gut? That is where the next part of the defense begins. In a sense, modern life has accidentally wiped out many of the good neighbors that once lived inside the human gut. Some ancient bacterial lineages that may have helped support healthy immune function were common in past populations, but are now missing from many people living in industrialized societies. As those beneficial residents disappear, the gut ecosystem becomes less diverse and some of its natural defenses may weaken. That creates an opportunity for harmful microbes from the outside to move in, establish themselves, and cause trouble. One of the first defenses used by beneficial gut bacteria is surprisingly simple. Occupy the space before an invader can. Imagine the intestinal wall covered with countless places where microbes might attach, except many of those sites are already taken by longtime residents. When harmful bacteria arrive with contaminated water, they may struggle to find enough room to establish themselves. Without a secure foothold, many are carried along with the contents of the digestive tract and eventually expelled before they can multiply enough to cause disease. But taking up space is only part of the battle. The second strategy is to starve the competition. The enormous microbial community already living in the gut is constantly consuming available nutrients. By the time an outside bacterium arrives, much of the food it needs may already be claimed by established residents. Now the newcomer faces two problems at once: nowhere to settle and too little energy to grow. A silent competition unfolds inside the body, with the larger, established community making life extremely difficult for any unwanted intruder. None of this means ancient humans were free of parasites. Archaeologists have found abundant evidence of intestinal worms and other parasites in ancient human remains, yet many infected people clearly continued living ordinary lives. Human bodies could sometimes maintain an uneasy balance in which parasites were present without constantly producing severe disease. Their bodies were not sterile environments at all. They were complex ecosystems filled with organisms competing, cooperating, and surviving together. And that brings us to a different kind of protection, one that existed outside the body. Biology was only part of the story. A mobile hunter-gatherer lifestyle may have been just as important in protecting ancient people from contaminated water. For much of the Stone Age, humans lived in relatively small groups and moved from place to place rather than remaining permanently settled. They often left an area before human waste could accumulate heavily around the same water source. When food became scarce or conditions changed, the group moved on. Without realizing it, that constant movement helped keep people away from some of the contamination their own camps could create. Human population density was also incredibly low compared with the modern world. Only a small number of people were scattered across enormous landscapes, with great distances separating many communities. For a pathogen, that created a serious problem. Even if dangerous microbes appeared in one water source, they might have difficulty finding enough new hosts to keep spreading. Once a group moved away or a chain of transmission ended, an outbreak could fade with it. Sparse population became an invisible barrier against sustained disease transmission. Movement also gave the environment time to recover. Once a group abandoned a campsite, human waste and organic refuse stopped piling up in the same place. Soil, sunlight, weather, and naturally occurring microorganisms could gradually break down much of that material. If people returned months later, the area had experienced a long period without continued human contamination, and local water sources could be cleaner than when the group left. There was no treatment plant involved. Time and distance allowed natural processes to reduce some of the contamination. Why deadly germs stayed weak. But this is where the evolutionary story becomes more complicated. In a highly mobile population, a pathogen that depends on close human contact may benefit when its host remains alive and active long enough to encounter other people. If an infection disables its host too quickly, it can sometimes reduce its own opportunities for transmission. A strain that allows an infected person to keep moving, on the other hand, may have more chances to spread. Under certain conditions, that can favor pathogens that cause less immediate harm. That does not mean ancient pathogens were universally mild, but in some transmission systems, causing fewer or slower symptoms could offer an evolutionary advantage. An infected person who remained mobile could continue traveling, hunting, and interacting with others while carrying the microorganism. The pathogen gained additional opportunities to reach new hosts simply because it had not incapacitated the person too quickly. It is a strange evolutionary trade-off. Sometimes the microorganism that harms its host less severely may have more time to spread. Repeated exposure to familiar microorganisms may also have helped shape immune responses over time, almost like constant biological training. Small, recurring encounters with microbes could keep parts of the immune system experienced at recognizing threats that appeared regularly in the environment. But this should not be mistaken for magical protection, and ancient people certainly could not drink safely from every puddle they found. Biology and mobility were only part of their survival strategy. The next layer came from something distinctly human: observing the landscape, remembering what worked, and learning how to choose water more carefully. Ancient humans were not simply drinking water at random. They developed a form of ecological intelligence by living close to nature every day. They watched the color of the water, noticed its smell and movement, studied animal tracks, and learned how the surrounding landscape affected where safe water was most likely to be found. Over generations, those observations became survival knowledge. So before a mouthful of water ever reached the stomach, another layer of protection was already at work, choosing the source carefully. One of the most remarkable strategies was following elephants to water. Elephants have an extraordinary sense of smell and can sometimes detect water hidden beneath dry ground. When they dig, cooler water may begin seeping upward from below. Ancient humans could take advantage of places like these, deepening the holes and allowing the water to pass through layers of sand before collecting it. In some landscapes, their water map may have begun with the tracks of a massive animal. They also followed a simple rule whenever possible: favor moving water and be cautious around stagnant pools. Fast-flowing streams are generally less likely to accumulate certain contaminants than still water. If river water was too muddy, people could dig a shallow hole into the sand beside the bank. Water would slowly seep through the surrounding sediment and collect in the hole, leaving some suspended dirt behind. It was a simple natural filter, but one that could make the water clearer before drinking. Once water was found, the next challenge was carrying it during long journeys or hunts. Our ancestors turned natural materials into portable containers, using things such as bamboo tubes, dried gourds, or animal skins. These vessels meant they did not have to gamble on finding a new water source every few hours. Some materials also helped keep the water relatively cool, which could slow microbial growth under certain conditions. The more water people could carry with them, the less often they had to trust an unfamiliar pool along the way. When a water source seemed questionable, people could also try to improve it before drinking. Sand and charcoal could help remove some visible sediment and impurities. Heated stones could be dropped into suitable containers to raise the temperature of water, sometimes even bringing it close to boiling. Sunlight could also reduce some microorganisms under the right conditions, while certain plant materials were traditionally used because people believed they helped preserve or improve water. The important point is that ancient humans did not simply endure dirty water. Whenever they could, they actively tried to reduce the danger before drinking it. The moment everything changed, then this entire system faced a massive turning point. Around 10,000 years ago, more human communities began settling permanently and relying increasingly on agriculture. The agricultural revolution opened a new chapter in human history, but it also created serious health risks. Once people stayed in the same place, their waste stayed there too. One of the great protective advantages of mobile life began to disappear. Growing villages created a new danger: crowding. Hundreds or even thousands of people and their animals could now live close together in limited spaces. Human waste, animal waste, garbage, and wastewater accumulated around settlements, while many families depended on the same wells, streams, or nearby water sources. Conditions that were difficult to sustain in small mobile groups became increasingly common. Once a shared water supply became contaminated, large numbers of people could be exposed at the same time. Dirty water could now become a highway for disease. A pathogen no longer had to depend entirely on keeping one host mobile long enough to reach another person. If human waste contaminated a common water source, the microorganism could reach many new hosts almost immediately. In dense settlements, waterborne diseases such as cholera and typhoid could become especially dangerous, causing severe illness and spreading rapidly through contaminated supplies. Permanent settlement had changed the rules of transmission. The cost of this new stability can even be seen in the remains of some early farming communities. Archaeological evidence from many regions shows that early agricultural populations sometimes became shorter and displayed more signs of dental disease, nutritional stress, and skeletal problems than earlier hunter-gatherer groups. Agriculture created permanent villages and more dependable food production, but it could also bring crowded living conditions, less varied diets, and greater exposure to contaminated water and waste. And that brings us back to the modern world. Clean water, sanitation, disinfection, and antibiotics have saved countless lives. At the same time, excessive antibiotic use and some aspects of highly sanitized modern living can disrupt beneficial microbial communities and have been linked to changes associated with allergies and autoimmune conditions. Ancient humans did not survive because dirty water was harmless. They survived because several layers of protection worked together: human biology, the gut microbiome, a mobile way of life, and detailed ecological knowledge. The lesson is not to start drinking muddy water again. It is to understand that health does not depend on absolute sterility, but on maintaining a healthy relationship with the microbial world that has always surrounded us.